like to thank our host SAP tonight, and if someone is tweeting about the event, we appreciate if you can share a little bit social love with us. We are with Hive Data, and we would just like to introduce briefly what the think tank is. Since our inception, we organized over 150 events with 8,000 database and with over 200 speakers. So the Hive Think Tank is a forum for entrepreneurship and all things data. Our 2015 was a very successful year. Thanks to all of you who attended our events last year with 83 speakers. We organized 29 events and we had over 7,000 attendees. These are our upcoming events until June. You can find all of them on our website, hivedata.com, and we post all of them on our meetup page as well. First 3 upcoming, maybe just to name few, in February 1, the blockchain and Bitcoin events, and in March, as you know, Hadoop is turning 10, and we'll have a talk with dog cutting. In March, more about the events on our website. Without them, with our sponsors, and partners, we wouldn't be able to organize these events, and we'd like to give a shout out to them, to all of them. And with this, I'd like to invite T.M. Ravi, Managing Partner, Co-founder of the Hive, to share more about the Hive.
Thank you, Sasha. So first I want to thank 2 sets of people. We have a partner here today, European Institute of Innovation and Technology, EIT Digital. Guys, there. So if you want to stand up. And so this is, the EIT Digital brings together entrepreneurs in digital innovation and education across Europe in 10 European cities. And second, SAP. So we're very pleased to be partnering with SAP, and after a few minutes of my introduction, we'll have the Chief Strategy Officer say a few words. So the Hive is a studio to create companies. So as part of creating companies, we also fund them. Our focus is on data themes, and so across 3 areas. Today we'll be talking, of course, about IoT, but IoT online and enterprise. And key areas of focus for us are data-driven enterprise apps, privacy and security, industrial IoT, the topic of today's conversation, blockchain, and blockchain as a kind of new distributed ledger-based infrastructure that is driving not just cryptocurrencies, but a lot of disruption in financial services, in security, in IoT, smart contracts, deep learning and machine learning driven automation in a variety of different areas, and then the kind of bucket of computer vision, AR, VR, applied typically to kind of UAVs, to drones and robots. So if there are any entrepreneurs here in the room and you're interested in these areas, reach out to me or Sasha after this event. Some of our companies are hiring. So a blockchain company called Coinalytics and a business process intelligence company called Neva. So if you're interested, reach out to me. Use the hashtag HiveData if you're going to be tweeting so that others can join in the conversation. And as Sasha mentioned, we have events almost every Wednesday. And so next Wednesday we have a good friend, Adam Back. Adam Back is founder of a company called Blockstream that is creating sidechains. So sidechains are sort of combinations of private blockchains or kind of integrating blockchains with the Bitcoin network. So very interesting talk. With that, I'd like to introduce Deepak, who's Chief Strategy Officer of SAP, to say a few words.
Good evening, and on behalf of SAP, I welcome you all to the Hive event that we are hosting. I just want to say a few words. Thanks Ravi for collaborating with us and hosting the event. Thanks Harel and GE for coming in, and GE is a great friend and a customer of ours, so we're happy to have you here. And just wanted to say a few words about why we are hosting this event over here. As you all know, IoT has gone from hype to something that's hypercritical for pretty much everyone in the enterprise, and SAP is clearly focusing on it across multiple dimensions. We have an open innovation platform called the IoT platform on HANA Cloud Platform that can help enable customers and partners build on top of our platform. We have end-to-end applications that can do predictive maintenance on top of our platform that can connect to our business process applications and ERP and supply chain logistics. And overall, what we are trying to do as a company is to work with customers, partners, startups, entrepreneurs to drive this end-to-end innovation and really capture value of IoT. A couple of introductions. So we have our general manager for our IoT here, Nayaki Nair, if you can stand up. If she's here, and anybody wants to talk to Nayaki, if you're a customer interested in what SAP is doing, you can talk to Nayaki. We also have Abe Kumar, who's from our partner team. Abe, if you can stand up if you're here. So if you want to partner with SAP, Abe is here. And SAP, as you also know, we have a corporate venture on Sapphire Ventures. So if anybody is interested in talking to our Sapphire Ventures, which is a top 5 corporate VC ranked recently. Max Vessel is here. Max, if you're here, Max is out there, and if anybody wants to talk to Max, you can talk to Max. I'm not going to take too much thunder from Harel, and I'm going to thank you all for coming here. We are really excited to host you here. Enjoy the cheese and wine and the snacks, and hopefully we'll have a great session. Thank you.
So I'll make one more plug to Mike Dobek here from GE Ventures. And so if any of you are trying to get something funded in the industrial IoT space, reach out to him. So with that, I'd like to introduce my good friend, Harel Kodesh. Harel is CTO of GE Digital. He's GM of Predix. Predix is, he'll talk more about Predix, but it's the middleware for the industrial internet. Maybe I'm not quite characterizing this the right way. It's an effort that has had a big impact in the industry. I would say probably frozen the market, and so now everyone's looking at sort of what GE's next step is. And so Harel comes with a sort of strong combination of entrepreneurial experience, corporate experience. He has been an executive at Microsoft, at Amdocs, at EMC, and of course now at GE. With that, so the way we'll format today is Harel will speak and hold your questions till the end, and then we'll have a Q&A session. With that, I give you Harel.
Now, this one? Okay. Ravi has actually changed the, reformatted the slide. So if I look at the slide and say, what the heck is that? That's, we have Ravi to think. So, GE does not do IoT. IoT stands for Internet of Things, and one of the things we figured out, or we realized, is that there's a fairly broad spectrum of IoT that ranges from, connecting Fitbits and communicating toothbrushes all the way to turbines and jet engines. Now, it's not just a matter of dealing with different devices. The challenge that we have from a commercial point of view is that on one side, it's very difficult to monetize the Internet of Things. It's those devices are really cheap. When people need to connect them, but they're not necessarily willing to pay anything for that beyond what they paid for the device. At the same time, when you look at a jet engine or a gas turbine, these are $20, $30 million devices, and they operate for 35, 40 years. And so there is a lot of impetus, a lot of rationalization to do something to make them even better. And this is where GE steps in. Our industry is a little bit weird. If you think about what happened over the last 20 years, one of the things that we see is that the business models are changing dramatically. If you look at Airbnb, you know, it's the world's largest hotel company without any single room. If you look at Apple, you know, they have an amazing ecosystem of the Apple App Store, but Apple is actually creating about 12 applications. If you look at Uber, you know, amazing complete change in the way that transportation is being done without a single car. So one of the things that has become clear to us is that we're riding on, as Bill Gates once said, tidal wave. You know, you can either stand on top of that or you can be crushed by it. Depends on what decisions you're making. In our business, when you look at the business of the industrial internet, as we call it, you know, we have unprecedented amount of devices. We have smart meters. We have turbines, or wind turbines, that generate data to the tune of several K every microsecond, and if you double that or if you multiply it by the 10,000 turbines that you may have in a wind farm, you're talking about unprecedented amount of data. If you think about it, let's do the math a little bit. Facebook, on the average, 1.5 billion users. On the average, you know, a Facebook users is uploading about a picture, sometimes 2 pictures to the cloud every 3 days. So if you look at that, these are actually a significant amount of petabytes. But those significant amount of petabytes are about an order of magnitude less than what you get from GE Aviation left to their own devices. So if you think about GE, a jet engine, a flight is generating about 300 gigabytes per flight, 100,000 flights a day, day in, day out, 365 days a year. You do the math, you figure out we're talking about close to an exabyte a day. So we are looking at unprecedented amount of data, and that creates a bunch of technological issues that we have to deal with, and hopefully some of you in the room will be able to solve it with us. GE Industrial Internet is not necessarily limited to the businesses that we serve. We serve about 6 or 7 sectors, you know, power and water, oil and gas, aviation, healthcare, energy connection or energy management as we call it. There may be 1 or 2, but we are looking at automotive, we're looking at agricultural technologies, we're looking at everything that has, in the middle of the business, has an asset that need to be monetized. So there are assets that people buy, you know, to have fun. I'm not trying to make any money off my Garmin watch, but there are assets that people are buying, well, companies are buying in order to generate revenues. And when they generate revenues, all of a sudden the idea of generating more revenues is becoming very, very compelling. The business is changing, not just, you know, for GE, but for GE customers. We're looking at a completely new job called Chief Digital Officer. And the Chief Digital Officer is building things that actually the companies that they're working for has not built before. If you look at companies, you ask companies about digital transformation, pretty much there is a consensus that the only way for them to survive will be to become digital. And digital, you know, this is going to be a little bit of a technological discussion, but digital is not just about the technology. Digital is about the ability to make decisions quickly and the ability to generate enough data to justify the decision or to create the right heuristics to allow you to make a decision. If you look at GE itself, within GE we have about 350,000 people. We lost a couple of tens of thousands to GE Capital when we spun it off. But overall there are about 30,000 people in GE that are working on digital related topics. And this is a significant amount of workforce. But what we need to do is build them a platform. Oops. Sorry. There are 3 types of internet that we know. 2 types are doing very well. 1 type is, well, a little bit left behind. So if you think about it, 1995, Microsoft is launching Windows 95. That's pretty much the firing shot for the internet as we know it today. Before that, you know, the internet was really the realm of universities talking to each other. You know, the first browser, Spyglass, Internet Explorer 1.0, Netscape start showing up on Windows 95. And so more or less we are 20 years into this revolution. And if you think about that, at one level we have the consumer, the enterprise internet. The enterprise internet was actually the set of the first beneficiary of the internet. Today you can identify it with companies like SAP, companies like Salesforce, and so on and so forth. The consumer side is on the other side. You know, Alibaba, Google, they all try to leverage the consumer side. And the interesting thing about the consumer is that the ecosystem actually has proven to have a lot of data. And then you have the industrial internet. So if, again, in each one of those internets, you go to the point where you have a platform, you have a set of applications, and you have the gestalt that allows you to actually create some interesting business. We argue that for the industrial internet, we have to do the same thing. The industrial internet is a little bit of a, until very recently, was a little bit of an oxymoron. You go to an oil and gas company, you really don't see a whole lot of internet there. You go to a pharma company, you see a pretty good scare about, you know, the connectivity in general. What if somebody hacks into the system and changes the formula or the way that medications or drugs are being manufactured? So we have a lot of reasons why the industrial world does not like the internet. That being said, at a certain point it became a little bit, you know, basically ridiculous that these folks that actually need the internet probably the most are not connected to them. How do you change, you know, a factory or a set of robotic infrastructure in companies that have multiple factories? Are you going to go with a DVD to each one of them? That's actually an option, but it's not a very, profitable or efficient option. And there's a bunch of use cases that I'll talk about later today that will show you that the industrial ecosystem has to connect to the internet. When we started with Predix, you know, the knee-jerk reaction was we had those, what we used to refer to as the never discussions. We're never going to basically do that. We're never going to get on the internet. We're never going to get these things connected. We cannot do that. And now the discussions are much more along the lines of A, I want to do it now, or B, I want to do it, it's going to take some time, but you know what, maybe I can do this and that, and let's build the use case for the management, for those companies to really change the way things are. So if you look at what we're doing, you know, the idea is to change the way that businesses are being done. The more conservative or the more traditional business of, let's say, a renewable company is to be able to put a bunch of turbines, you know, charge them for the turbines, have them generate power, go and price the power so they can sell it in the open market. A different thing will be to say, look, you know, this is all going to be power by the hour, right? We're going to sell production. We're not selling you the turbines. Actually, we're giving them away. The only thing you have to do is pay us based on the production. If you generate 4 gigawatt, you know, you pay for that. If you generate 14 gigawatt, you pay for this. So all of a sudden the discussion changes because GE is no longer, and I'm sure that many other companies are doing it, is no longer the producer of cost. We are actually changing the interest to align completely with our customers. So when the customers don't generate revenues, we cannot charge them. If you think about GE Aviation, it's another example for power by the hour. It used to be that we would sell the engines and the customers will look at them, you know, we'll put them on the wings of the planes. I don't know if you know, but when United Airlines buy a plane, they buy the body, the airframe from Airbus or Boeing, and then they buy the engines and they can buy it from us, from Pratt & Whitney, or from Rolls-Royce for most cases. And it used to be that, you know, we sold them the engine, we walked away from that, and that was either their problem or some maintenance company's problem, and we didn't have to do that much. And it didn't generate a lot of alignment in the interest. We changed the business several years ago to move to power by the hour. So now we are at the point where we are selling not necessarily the engine, but the thrust that the engine generates. So if the engine is not on the wing or the engine is failing and something has to be done about that, As long as it's not in the wing and the plane is not flying, we're not making any money because there's no thrust, because there's no flight. So all of a sudden, the businesses, who are for most part capitalistic pigs, decided that they're going to basically change the way they do business. They created teams that will be able to summon at a moment's notice and fly them to God knows where to basically serve an engine that, on a plane that was grounded. They created technology that allowed them to serve the engine while it's still on the wing, so they don't have to take it off the wing and put it on a big truck and send it to the depot. When you think about that, why didn't they do it before that? Because before that they didn't have any reason to do it. Now all of a sudden, if the engine is not flying, they're not making money. So this is one thing that we are seeing in terms of the digital transformation. The other one is the cloud-based platform. I talked about the fear, but at the end of the day, the only way for us to really optimize the outcome of a power company, a power generation company that has a bunch of turbines, is to be able to monitor the turbines and tell the operators some non-trivial things about what's happening. How are they going to change the way the turbine is being maintained? So let's think about that. Most of the organization industrial ecosystem live based on schedule-based maintenance. In other words, there is a bunch of crews and there is a bunch of machines, maintenance machines that are moving between the various turbines, and one day they're going to serve that turbine. The truck is going to go and serve this turbine some other time. And between all these, and this is a schedule that can be done months, if not years in advance. All of a sudden you say, look, instead of serving the turbines every 3 months, why don't you start looking at the data? The turbine has a lot of sensors. And so the thing that you want to do is to make sure that you look at all the sensors and you say, look, I realize that there is actually a downward trending of what the turbine is doing. So instead of looking at the turbine today, you can say, look, in the next 2 weeks, you're going to lose 20% of your performance because the turbine has a bunch of gunk on the blades. You have those blades, and if the blades don't have a good smooth airflow, then the performance of the turbine is deteriorating. So instead of waiting 3 months, when you know that you have a problem with the turbine today, why don't you just go and get what we call water washing, which is a big hose you connect to the turbine and you just basically wash the blades. Do it as soon as possible. In fact, do it tomorrow. Now, it is an interesting problem because not only you have to analyze the turbine, you have to compare it against various operational models, you have to compare it with other turbines, you also have to change the way that those companies work, because now, like in the GE Aviation case, you have to call a crew and have this big hose, this big washing machine, and actually make it available close to the turbine, within 24 hours. So we have all these decisions that are actually, at the end of the day, are convergence of operational technology and information technology. It used to be that those companies have, like GE, have two camps. They have the people that deal with the machines and the people that dealt with the general ledger. And those people did not talk. All of a sudden, we have to make sure that the information is available to everybody. In GE itself, we need to make sure that we have, we are accomplish our goals. Our goals for this year are only $5 billion. We are trying to get to $15 billion in 5 years, and if we can accomplish that, that's going to be the world's largest growing ever, software company. But that's not easy. We have many people, and as many of you know, sometimes many people is not necessarily a blessing. It's a little bit of a burden that we have to deal with. We are present in pretty much every country, which is great. We are trying to sell not just the stuff that we're building, but the stuff that folks like yourself, other startups are building. And I'm very proud that GE, this huge company that used to be known as a startup killer, because if they hate you, they will never talk to you. If they love you, all 100,000 of people will talk to you, and they will take you out of business. We managed to basically find a way to deal with small startups and actually make sure that we are doing it gently. And it was an interesting experience, because when you look at that, I had the good or the bad fortune to work with those companies when I was in a bunch of startups. And it takes you about 6 months just to find out who you need to talk to. And then it takes you another 3 months to realize the guy doesn't have a budget. It takes you another 6 months to find the guy with the budget. And by the time that you found this guy, that guy's left the company and you don't know what to do. So now we are trying to basically do it much faster. And frankly, we are willing to share the risk of the small startup because we know that if we are asking the startup to scale their maintenance agreement, scale their presence in the 100 countries that we serve, we will kill them. So we're trying to make sure that we get the ingenuity of the community without throwing too many monkey wrenches their way. I think if you look at what we're going to talk is about I would like to do is talk about some of the areas that we are active in, and then dive technically into one area that I think we are making huge progress, which is really the edge computing. Because we're not going to talk about the cloud. I think most of you know how the cloud looks like. I can talk about why the industrial internet cloud is different and why we're building whatever we're building. But it's really going to be the edge computing that I think is going to knock the ball out of the park. So, one of the interesting things that we had, for instance, in intelligent environment, which is we call the new business of going into actually a whole city and enabling a bunch of new scenarios, is the fact that those scenarios are very well integrated. I was in Singapore the other day and I talked to the Minister of the Interior, and he said, look, I would like to be able to provide all kinds of multimodal services for the citizens. I said, what are multimodal services? He said, look, if there is an apartment, and this is Singapore, so take the privacy issues with a little bit of a grain of salt. But he said, look, if there is if there's an elderly couple sitting or living in one apartment, and I know that the water is flowing there for hours, then I would like to send an ambulance to see what's going on. And while I'm at that, I'd like to make sure that the traffic lights are green, and I want to make sure that it's all connected to the ambulance. So when I finish the flow, elderly couple need help, I can actually stop the ambulance support routing and lights and go back to normal operation. So when you think about that, that requires, and in the US it will take probably about 297 years just to make it work, because you have to deal with all those little authorities. But the idea is that cities are going to benefit from putting all the data in the same place, which obviously brings issues of security. We'll cover that in a second. But it's not enough. It's in order to basically create the intelligent cities, we need to create what we call intelligent infrastructure. And one of the things that we're working on, which I think is at this point, there's you'll hear other people from GE saying that they got it nailed, but I would argue there's more holes than cheese in this business right now, which is great because you guys are producing the cheese, so we can plug the holes. Is that if you look at what we're trying to do, we're trying to be the world's biggest repository of what we call digital twin. And what is a digital twin? So think about that. You have United Airlines. If I'm not mistaken, it's about 2,500 planes in the US, running back and forth. You want to create a cyber space a cyber twin to each one of those engines, not just the GE90 LEAP engine, which is a category of engines, but that specific engine on the right side of that plane with a specific tail number. If you think about the transition that Google, or the revolution that Google and Amazon have introduced, they moved from a demographic model where they know that Harel is, basically such and such a security number, living in such and such address, to a psychographic model that they know, in which they know many more interesting things about me. They don't really care about my address, but they care about the fact that I send, twice a year, I send gifts, one to New York and one to Palo Alto, because I have relatives living there. And by the way, from those addresses, they see that there are tickets being booked to Seattle, 3 times a year. So all of a sudden, they understand exactly what my patterns are, right? They know that at a certain point, it may be a good opportunity to offer me all kinds of gifts to buy for those people that they manage to figure out I'm connected with. We want to create the same thing for every device in the market. It can be a vending machine, it can be a digital a jet engine, and it can be a wind turbine. For every device, every physical device we're going to have in the real space, we're going to have something similar, very similar in cyberspace. So when you think about the vision is when you think about the plane flying over the Middle East. The Middle East has its own set of pollutants in the air. You know, mostly sulfur because there's a lot of gas and oil sediment. So the vapor goes up and you have a lot of sulfur in the air. In China, you have also pollutants, but the pollutants are different. They have more calcium there, right? So all of a sudden, what you want to do is you want to take the input of the environment, you know, the winds, the temperature, the pollutants, the chemistry of the pollutants in the air, and you want to stream it through the digital twin so you can start creating a model for when the engine is going to deteriorate. So rather than wait for a flight to take off and then the captain comes up and says, we cannot fly the plane because I get all kinds of signals. And sorry guys, we'll try to fix it. 3 years go, 3 hours go by. Sometimes it feels like 3 years go by and nothing gets fixed. And then they find you another plane. You can do it before the plane starts even flying, right? So that's the idea of digital twin. You can anticipate what's happening, but that requires a significant amount of information and then significant amount of ingesting capabilities and analytics capability to allow us to give the operator the specific insights into that specific device. Again, not the generic device, but that specific device. And that's what we are, when we talk about digital twin, that's what we mean. As I said, the service transformation is going to change, basically multiple billions, many probably hundreds of billions of dollars in the space. We look at the things that we are doing, and they're so big, and the amount of revenues is so huge that just by changing something relatively in a small way, you can save hundreds of millions of dollars. So, there are examples here, but I'll give you an example I like even better. The average speed of most of the goods in the United States and actually all over the world is still shipped by on railroad, right, on trains. The average speed of cargo trains, or actually the average speed, of cargo trains is 21 miles per hour. 21 miles per hour. There's all kinds of reasons why trains stop in the middle of nowhere. Either it's a side wind issue, crack in the tracks, all kinds of things. If we can anticipate some of those things and actually get the average speed to be 22 miles per hour, the industry will save $300 million a year. So we're talking about huge numbers, unbelievable multiples. It's power generation is also a very rich business. We're talking about, when we do the savings are starting to pile up very quickly. And that's why our customers are willing to pay for what we're building. This is not, again, no offense to consumer internet, this is not something that we offer for free. This is not something that anybody expects to consume for free. So this is what we built. This is the Predix stack. A lot of that is actually, we announced general availability today. Well, we haven't announced it, so you're the first one to know. But outside the building in San Ramon, you are the only one to know that we are generally available today. And we have really three, I would say actually 4 tiers of functionality. It's important because I'm going to start diving into that. So at one level, we have the cloud. If you think about an Amazon or Microsoft cloud, usually there are 2-tiered systems. You have the cloud, and then you have on the other side a set of devices that the cloud is talking to. You don't need anything in between. You don't need concentrator. When I look at my AT&T iPad, it sends information and it goes to the cloud. We cannot deal with that for a bunch of reasons. So let's look at what we can do. If you think about all the layers, we have the layer of the cloud, and then we have the layer of the business continuity. If you're running a grid, if you're a grid company like PG&E here, and you want to create a grid management system that allows you to withstand storms and rains and all kinds of inclement weather, you're not willing to trust the cloud 100% of the time. As long as it's a nice day, no problem. But if you are the COO of this grid company, you're asking yourself, what's going to happen when the weather turns south, right? How am I going to basically run my business, and how am I going to know that a certain transformer is going to fail when the weather is inclement? And this is exactly the time where I need all these analytics that G has built for me. So what we built is what we call the Predix box, that is the next layer. It sits on premise, it doesn't depend on the cloud, it is intermittently connected. So as long as it's connected, you have microservices that are synchronizing between the cloud and the box. But if you don't have the connectivity, that's fine, you can still work. And then you have, let me skip through layer tier 3. Tier 4 is the edge device. So you look at the wind turbine there. The wind turbine, or every other machine, has a controller. Controller is not a big machine. It's usually a 4-core CPU-based controller. It has a bunch of hypervisors there that can run the real-time OS and can connect to Predix. But the problem is that you cannot just rely in many cases on the single machine. If you think about a wind turbine, 100 turbines, right? So they stand in all kinds of places. And the turbine, the controller in the turbine is actually changing the pitch of the blade in such a way that it is maximum alignment or disalignment actually with the wind, right? You want to have, those of you who fly, you want to have a perfect angle of attack so you can actually generate maximum thrust or maximum torque. Now the problem is that when a turbine gets optimized, it creates wave turbulences behind that, so the turbine behind that is now get de-optimized. As the operator of this wind farm, you don't care about optimizing a specific turbine. What you do care about is optimizing the whole thing together. And so what you need is what I refer to as tier 3, which is a gateway and a small controller that allows you to make very quick decisions there, allow you to normalize the data, cleanse the data, and then upload it to either the Predix box or the cloud. And so these are the 4-tier system that we have. And by the way, that's why we had to build Predix, because if it wasn't for that, and if it wasn't for the different level of security that we need, then we may just as well go and work on Azure or work on Amazon and not be in the PaaS business, just be in the SaaS business. We had to do that because the industrial internet, frankly, is not like the consumer or the enterprise internet. It has completely different constraints that we have to deal with. Predix is predictive, right? That's why we call it Predix. It's not, you don't have to be a rocket scientist to figure that out. But the interesting thing about Predix is that it is global. We have to deal with, and I think that any of you that wants to be in the industrial internet will have to deal with what we call data sovereignty. Countries are willing to let their users post pictures on Facebook, even if the user is French, living in France, and the data center is in Amsterdam. But countries are not willing to do that with either industrial data or health data. And the reason is that most of the industrial data belongs to what they call critical infrastructure. So critical infrastructure is something that France is not willing to entrust, not even in Germany, not even in Amsterdam. They want to have it stay in France. So when we do that, we have to go and put points of presence in pretty much 140 countries, which is comparing to Amazon 20-some availability zone, Microsoft, 30-some data centers. It's a completely different ballgame. Now it forces us to be much more fragmented, but that's something that just comes with the territory. We have to figure out a way to do that, a way to do it quickly. It's an open ecosystem. We didn't try, and a lot of lawyers in GE got, fainted over that because the GE, normal course of operation is that when you build something, you want to keep it for yourself. You paid for it. All of a sudden, this huge company is waking up to a situation where you have open source community. If you don't contribute, you don't have a say. And so we managed to basically get the lawyers, warming up to the fact that we have to be major contributors. And if you look at the contribution on Cloud Foundry, on a bunch of the other things that we're doing, you'll see that GE is pretty active there. So, as I said, we have the 3 areas that we're trying to focus on. developer ecosystem, everything we need to do for the digital twin, which requires a different level of ingestion, we simply cannot, you can use Spark to ingest a lot of objects into the system. When we look at digital twin and you look at the volume of data, most of those things actually break because we have to decide how to prioritize certain things. So you think about that and you say, look, if I had enough bandwidth, I can just ingest everything that is coming my way. But let's assume I don't have enough bandwidth. Let's assume that those 1,000 turbines, generate megabytes a second, and I simply don't have enough bandwidth to ingest all of that. What should I ingest first? Should I ingest, the reading from the temperature sensors, or should I ingest a reading from the torque sensors that will tell me the turbine is about to go bust and blades are gonna start flying all over? Probably it's the latter, right? So all of a sudden we have to start prioritizing things, and there's no ingestion system that available today that allows us to do this prioritization. And last but not least is the edge, and the edge is what I'd like to spend most of the remaining time on, because if you think about the edge, the issues that we have is that the cloud does not give an answer for everything. If you are Shell Oil and you operate a subsea drilling system, you're not going to entrust your blow-up preventer to the cloud. The blow-up preventer is the thing that didn't work in the Horizon, oil spill disaster. It's if you look at the drill, you have the hose that actually take the oil up, and then what's happening when there's something wrong is going on. There's a bunch of clamps on the hose that actually shut, and they're supposed to sever and lock the oil flow. That obviously didn't work when BP went bust. And the idea is that when these things start basically happening, God forbid, no sane operator is gonna trust that the cloud is gonna respond to that at the right time. Connectivity is down. There is some problem with one of the jobs. All of a sudden, you have thousands or millions of gallons flowing in and billions of dollars in fines, and you don't want to risk that. So what you want to do is you want to be able to take the workload and actually move it to the right place. And so these are the areas that we try to solve, but as I said before, we didn't assume that we have all the answers. We've been working with a bunch of companies, some of them are sitting here, to make sure that we can come up with a solution. But let's go back to what we're trying to do. So the reason we build developer ecosystem is because all our businesses, be it oil and gas, energy management, agricultural technologies, Pitney Bowes, Toshiba that we already announced, aviation, power and water, renewable, which is a new business, they all have they have the applications that we build for them. But you know what? We are actually covering a very small amount of the application. APM is our asset performance management system. ALM is our asset life management system. We can optimize the operation, which is what we refer to as OO, and we can create a much smarter process in the manufacturing space by Brilliant Factory. So Brilliant Factory is the ability to understand what's happening on the manufacturing floor, which is in SAP, you know very well that you know exactly what's happening in the warehouse. Once you put the material on the manufacturing floor, they start morphing so quickly that sometimes you lose visibility. And one of the things that we need to make sure is that if you go to a Boeing 787 Dreamliner manufacturing floor, you have tens of millions of dollars in material there that nobody is accountable for. So this is what we're trying to do by Brilliant Manufacturing. But there's many more applications that we are not going to build. As I said, Apple is creating an amazing ecosystem with only 12 applications of their own. I hope that we'll create an amazing ecosystem with only 8 applications of our own. Everything else is going to come from the community, which is why we need to make sure in GE, which is not intuitive, that we are a great developers ecosystem provider. The company was not born into the software, so but the good news is that people understand what we're trying to do, and they're coming in, and we're more than happy to hire many of them to help us doing that. But when you look at that, we want to really focus on the edge because this is the area that actually Predix normally was not, or traditionally assumed a very simple edge structure. This is our roadmap. We are going to, we are now in GA. Next year, we're going to double down on working on what we call Predix Fog and the Predix Box and the Predix Digital Twin that will allow us to get much more optimized to create all those devices that today we don't have yet. One of the things that we see in the system today is that there is a data addiction going on. If you look at the engines, even from 3 years ago, the amount of sensors they had was nothing to write home about. And the amount of data they took was nothing to write home about. They would take a jet engine would take 1 second of data, during climb, 1 second during takeoff, 1 second during cruise, and they assume that everything is going to be the same. But it's not good enough because things are kept failing, and there was no statistical or analytical model for us to go and explain them. So the digital twin will allow us to do that. And the digital twin is depending on a much more sophisticated set of edge devices. So as I said, there are actually 4 layers on what we're building. Even if you leave the cloud, you have the box that comes in actually rack enclosure. You have the gateway, and then you have the Predix improved edge device that will allow us to do the things that we want to do. There are 3 layers or 3 functionalities that we would like to create in the box, and we don't have all of that figured out, but we are pretty close. One is the ability to manage those devices. Every normal enterprise buy Opsware or HP OpenView, and with that they can see exactly what edge devices they have in the system, right? The edge device being servers, routers, printers, everything that you accept in an office environment. You go to some of our customers and you get just, those of you or those of us who live in the Bay Area are just shocked by the amount of, or the lack of information about what devices are. Nobody knows exactly what's going on in an oil field. A technician wrench time, which is what we refer to the real time, or the amount of time the technician is actually free to perform maintenance, is 18%. So 82% of their time they're jumping into pickup trucks, drive about 5 miles out, go to one of the pieces of equipment, lift a little door, read the LEDs, write on a clipboard, go back to the office, put it in Excel. That's horrible. I mean, when you think about that, there's no reason why in a connected system we'll not be able to figure out exactly what's going on. But the fact is that we can. So the first thing we need to do is the discovery element. There's a bunch of interesting companies that are working on discovery to give us actually a pretty good view of what's happening. We're not the only one, they're not the only industry that is dealing with that. The telecommunication industry was also dealing with, especially in the fixed line business, with all kinds of equipment that was laid out 40 years ago, and nobody knows exactly what's going on. And if you talk to the 65-year-old technician who's about to retire, will tell you that 40 years ago, somebody put something behind that building. So we are all depending on those secrets, and this is not really a way to run a business. So discovery is first. The second thing is the patch management. Those controllers need to change. If they don't change, they become really old, and you need to really retire them or build something else. Especially when you start looking at controllers that's supposed to support robotic arms and robotic manufacturing that need to be managed all the time. And this is where the next level of concern is coming up, which is security. The companies that we're dealing with are terrified, right? I mean, people are breaking into Sony and show all kinds of pictures of naked actresses. With all due respect to the comic value of that, this is not plunging LA into the dark. And so the companies that we're dealing with, this is what they're concerned about, that either, basically nation state or just pure hackers or, terrorists are going to hack into the system and pretty much, hijack our way of life. It's very easy to assume there's power, all kinds of things you can do with that. Try to imagine your life without power. And when you look at the, I'm not telling you any, I hope I'm not telling you any secret, but the level of security in those systems are very naive. Now, people come to us and say, why don't I connect to the cloud? The cloud brings all kinds of impurities, breaches, and so on and so forth. And the answer is that, if you don't know that you have Windows in your home, you're not going to bar them. If you have Windows in their home, you can bar them, you can bar them effectively. So, most of the breaches happen in companies or in power utility companies that thought that they are completely disconnected from the internet. But what is the being disconnected from the internet? If the secretary is asked to produce production report, and the way for her to produce a production report is to connect the operation technology network to the printer, she just created a coupling between OT and IT, a coupling that nobody knows about. And now, this whole thing is open for every hacker that wants to play with that. So what we want to make sure is that nobody will be able to access those controllers and stick a USB card and play all kinds of things, which means that we need patch management. We don't have, the world still doesn't have a good patch management system for industrial systems. And the last but not least is the fog element, which allows us to move workloads from the cloud through the gateway to the edge devices and run them at the right place based on the capacity of that specific device to run it. There is, if you look at the amount of sensors that those machines are going to create, not only we have to make sure that we analyze all this information, we have to make sure that we only upload the right information to the cloud. 40% of our data is dirty, which is usually not the case in cameras. When you load the picture to the web, you load 100% of the pixel. Maybe you load less than that if you do the right compression, and it's a little bit lossy, so you may load, much less than that. But it's not because the data is meaningless, but because you can live with lower resolution. In our case, we have spurious data. We're talking to agricultural technology that we would like to seed the field or the range, with sensors to tell them exactly what is the humidity in the ground, and then seed it with a wheat. And then once the wheat grows and they deploy the combines will be able to talk to the sensors to see exactly how much moisture there is in the ground. If you pull the needles of the combine too deep, you apply a lot of torque, you shorten the life of those needles. If you don't pull them, you don't stick them deep enough, then you can't harvest the crop. So what they want to do is they want to know exactly how far and how far they can stick the needle in and how hard is the soil. And for that, they would like to get a bunch of sensors. Now you can imagine some of the sensors are going to get completely defective. They're going to generate all kinds of spurious reading. The important thing for us is to make sure that we can cleanse the data, normalize the data before we take it to the cloud. If we make too many mistakes in too many installations, we're just going to have probably order of magnitude more than what we need. And these are exactly the things that we're trying to do with a lot of the sensors and making sure that all the data is relevant. We also make sure that we can create enough analytics on the edge because we simply don't have enough time for the cloud to respond to something. Again, we talked about the wind farm, data every microsecond. You have to change the blades. You're not going to go to the cloud. The turnaround time, the latency is way too high. So you have to do certain things right on the spot. That being said, operating on a strategic level, the wind farm is something that probably can be done with enough latency and the cloud is just the right place for it. So we have to make sure that we know how to move that. And then, obviously, we want to make sure that from a regulation point of view, from security point of view, those edge devices are going to be secure enough and protected enough. There are certain other areas that we would like to talk about, would like to deal with, which is really the software-defined networking for a bunch of things. We want to make sure that because we are operating globally, we don't want to build something for Telstra and something for AT&T and something for France Telecom. We want to make sure that when it comes down to communication, we have devices that need to move data from point A to point B. We're asking the carriers to help us at the data link layer to move things from point A to point B. We're asking them to let us run the policies on top of that. So that calls for a software-defined network. If you think about a hospital, From a HIPAA compliance point of view, the data, the wireless network that allows you to read the bedside monitor cannot be the same network that the relatives of the patients are using to write mails. So they need to have two different networks. But let me tell you a secret. When you look at most of the Wi-Fi networks in hospitals, they're not HIPAA compliant. They're open to everybody with a minimal amount of hacking capacity. And so what we want to do is we want to make sure that the policies and the enforcement of the policies is kept at a higher layer rather than creating a mishmash of networks from Cisco, from Arista, from this, from that, and all of a sudden we are faced with a situation where the hospital or any other secure company cannot run their business because there's too much to control there, and these companies are not what we call knowledge enterprises, they're just hospitals. I won't cover all of that. I want to make sure that, again, I'll give you the gist of that. It's a little bit difficult to read, it's too small, but in 2016, that's going to be our emphasis. The cloud is growing. We have about, we just announced GA today, and we have about 4,000 people on the network. They're banging, they're creating all kinds of interesting applications. By the end of the month, we're gonna release the network to pretty much, or release Predix to everybody that wants to use that. Predix.io is where people go to sign up for, and you can sign up for it today, and in 2 weeks you'll be able to bang on the keyboard and generate that. But the important thing for us is really going back to what I said before, is create a community of innovators in the industrial internet. Some of them will work, some of them we will even invest, some of them will may even acquire. But the idea is to make sure that we are not in that alone, because frankly, GE, as big as it is and as rich as it is, cannot solve this problem alone. There are many people that have great brains that will simply not come and work for GE. So we recognize that, and we're trying to make sure that we deal with the situation in a way that will allow us to build a great community. We want to make sure that we energize the community with a bunch of things, everything from hackathon to challenges to just working with some innovators and entrepreneurs that look at us and say, well, I've seen Predix, I know where the holes are, and I know how to plug them. And if that's the case, come and talk to us. And I think many of the companies, I look at the signs, many of the companies that are here did talk to us about how they can help us, and we are actually actively working with them. I want to go back before I finish to the digital twin, because I said that Edge is going to be one of them, but it's going to be one of the emphasis, or one of our the areas we're going to double down on. But digital twin for us is huge. Not only the ability for us to build digital twin, but the responsibility we have for our customers. If you're United Airlines, you're not running GE engines only. If you are PG&E, you're not using GE turbines only. You're using Siemens turbine, you're running Pratt & Whitney engines. So we want to make sure that our customers will be able to control their whole fleet with our software. Now, our software is not running on GE IT servers. Predix is, think about Predix as digital Switzerland. It's something that is, GE is our main, well, it's our only funder. GE is also our biggest customer, but we're not putting other people's data in GE, on GE properties. So that's why the Predix data centers are completely separate from our IT systems. Before I finish, let's talk about what we need to do for digital twin. And this is really on the orchestration and semantic side. You want to create a model of a system. How do you create a model of a system that has 100,000 parts, right? And so the thing that we want to make sure is that we create a knowledge graph of everything that we have in the device. We create an authoring environment that will allow us to take advantage of this knowledge graph and create the semantics of the device. And then we want to make sure that we can have a schema that takes the data and actually understand exactly what this data belongs to, and then we can analyze that. So if you think about that, this is the functional overview of our digital twin. At the lower layer, we have the abstractions of assets. What is an asset? How do you define an asset from multiple subcomponents or subassemblies that are in turn defined by multiple components? Again, a locomotive has about 50,000 parts. You want to make sure that you can ask all kinds of queries. Some of them cannot be answered by normal relational database technologies. So we have that, but then we want to make sure that we have the knowledge graph that not only identify the semantics of how you build this device, but also start to reach out to map between that and a bunch of Hadoop cluster data or ADFS data that actually aggregate all the experience that you have with this device, and that in itself allow you to build the model, the catalog for the models. The catalog for the models can be orchestrated in a variety of ways, either by us or by competitors, and build something that is much bigger than what we've done today, which in turn creates constraint on analytics, constraint on ingestion, and constraint on visualization of the data. We have the ability to connect to Predix. We are working on the app composer that allow us to actually create a digital twin in a fairly easy visual way, and then we want to make sure that we can take those digital twin and unleash them on the community in such a way that they will be able to learn and create their own analytics. So in the past we couldn't drop a jet engine on developer's desk. Now we can do that through this composer, application composer. As a result, everybody in the Bay Area can work on jet engines now. I'll skip that. There's a bunch of things that we're trying to do to accelerate the progress. Everything from marketing assistants, working with you or anybody else that want to work with us, providing them with a document, making sure that we have simulations and simulators to a variety of devices, encouraging the construction of new simulation for devices. And at the end of the day, making sure that we provide channel ecosystem for the business folks among you. When GE Salesforce go and sell a solution, we're not only selling our own made-in GE solutions, we're also selling partner solutions. Because at the end of the day, we can sell solutions that we created, or we can be a publisher that sells other value nodes. We're working with a company that does interesting things in analytics about scrap minimization, right? So how do you make sure that you can track, the raw material in such a way that you minimize the amount of scrap? We didn't write a single line of code, but our customers are very interested in what this company has to do. And all in all, there are about 20 people. We have about 100,000 people in the sales force. So it makes sense for them to work through us. We're not doing it for charity, but we also allow the company to get to a much higher level than they would have done if they were depending on their own sales force. I will skip the digital thread, but maybe I'll talk to you about 2 minutes. I have 2 minutes, right? The digital thread. The digital thread is something that allows us to actually connect the ERP systems through Predix, and by doing that, making sure that we know what's going on, and we can optimize our factories. We can make sure that at the end of the day, all those great insights can be translated into the outcome, especially on our manufacturing floor. We have 145 manufacturing floors, and we think that it also applies to 14,000 factories in everything from food and beverage all the way to electronic manufacturing. So we believe that at the end of the day, if we look at all these things, we will be able to realize $2 billion of productivity from GE alone by the end of the year. I talked about cyber. I think I'm running out of time, so I don't want to dive too much into that. But as I said, the idea of cyber is very scary for our customers. We provide them cybersecurity within Predix, but we also provide them cyber services in terms of situational awareness. When you see that an IP address is very active in an area in South America where power utility companies are getting breached left and right, then we would like to make sure that this IP address is known to folks in Western Europe. So when they see something, they will be able to start correlating that, and these are the services that we provide to our customers. At the end of the day, you can see that we're working with a lot of people, and frankly, we need to work with many more people. There's not enough as much as we like it, we're just in the beginning. Predix, in its current incarnation, is about a year old. It is CI/CD system, so we continuously integrate and deploy our services. So we don't expect to have another generational leap for the next probably 7-8 years. And we need many more partners to work with us to start building, the things that we need to build. It can be system integration, it can be big companies, it can be small companies, it can be telcos, it can be the whole shebang, and we need to make sure that we know how to work with them. So if you have something that you don't like about the way we work, just let us know, and hopefully we'll fix it. Look, our strategy is first we do it for GE because, like in the AWS for Amazon case, GE has an amazing scale. So for us, it's really a good test drive, but it's also allow us to move beyond a certain scale that otherwise would not be able to do that. Once we are at that scale, things get much cheaper for everybody. And so then we're going to go to the layer of our customers, and then we're going to go beyond the normal layer of GE customers to do it for everybody. And I hope that in the next 5 years, 20-30% of Silicon Valley is going to work on industrial internet. Then we'll know that we've arrived. Well, thank you very much.
Sasha here has a microphone, so raise your hand, and maybe I'll start with the first question.
Sure.
And this is related to sort of the open ecosystem and just Predix as a platform. So how do you see the competitive environment? You have on one side industrial vendors like Siemens and Rockwell Automation, ABB, Schneider Emerson, and so forth. And then on the other side, you have people who have been doing software and cloud for some time. SAP, Microsoft, IBM, and
Right.
so on. Do you see sort of Predix being an open platform that embraces them? How do you see that?
So, Predix is open platform that embraces everybody, but, we live in the real world, so we know they're going to be, basically easy cases and tough cases. I think if you, again, no offense to them, but I think they're a very proud company, very good company, but Siemens is not going to, basically just fall, basically into our arms and say, okay, well, I saw the light, right? But that being said, there are a lot of companies, industrial companies, that look at that, and in terms of the size, they look at it and say, well, actually it's not going to be bad to throw our lot with GE, and I think that you'll see in the next several months, a bunch of the deals that we're working with will demonstrate that Predix is really not a single owner. I'm not talking about the capital ownership, but a single owner from the IP ownership. It's not a company that's only backed by one player. I always look at that as the car. I used to work for Ford, so they always gave me this example. In 1928, there were 278 car makers in the U.S. because all you needed to have is a bunch of folks that doesn't ask too much in terms of wages, a chassis, a steering wheel, and maybe a roof every once in a while, and you had a car. At a certain point, customers start to ask more and more and more, and so you got the consolidation that eventually got us to the big three in Detroit. So I think that at the end of the day, people are going to realize that building a business like Predix, it's just, it's time consuming, it's capital intensive, and if you can work with GE and take advantage of the scale of GE, why not do it with us? I think that I don't see us collapsing into a single case, because I think that a lot of companies would like to compete with that. But I can tell you that I think in a year you're going to have 90% of these companies taking sides, and in 5 years you're going to have probably 70% of the remaining 10% consolidated, because what everybody wants and what everybody needs to have is really the SaaS layer. The infrastructure and the platform layer is something you do only if you have enough scale to justify it for yourself. I believe that we are on that right side of the scale. Most other companies are not, and this is not bragging, it's just realizing that G is G.
I think I can feel it, that you'll get the kind of smaller vendors and so forth, but to get someone like Siemens, for example, maybe follow the software path, which is everyone in software is, the software trend is open source.
So we are, look, we are ready to basically release significant amount of Predix to the open source. We have no problem with that. I think that Siemens at the end of the day will come, but it's really going to be based on our customers. Most of our customers are multimodals. Nobody's, for a bunch of reasons, reliability, redundancy, playing one side against each other, against the other. Our customers actually usually have Siemens and GE, Pratt & Whitney and GE. But if you put yourself in the shoes of the VP operations, do you really need two systems to deal with two very similar jet engines or turbines? The answer is no. Now, you can choose the Siemens part or the Pratt & Whitney part, or you can choose the GE part. We're going to make it very easy for our customers to go in and tell Siemens that nothing is going to happen to them. They're not going to lose, any competitiveness if they're working on Predix. Again, as I said, this is not, they're not taking and trusting their data to GE IT servers. Predix is completely separate.
So your platform will support a variety of different machines from any vendor?
Absolutely. Absolutely.
Question?
First of all, thanks for very exciting speech. My question is about security, and when you're talking about security, it's important to ensure that it goes all the way from the source where your data originates, and you don't have any gaps to the place where it's where you store your data, where you analyze it, and where you view it. And given the extensible nature of your platform, so you allow different hardware solutions to communicate to Predix Cloud, you allow different connectivity providers, etc. So what's the process of ensuring that you don't have gaps, and so what's the procedure of, when your client, like the company, wants to ensure that it's secure? And a small additional question. So do you have any plans of using maybe machine learning AI-based like anomaly detection and security, and for digital twins as well? Thanks.
So excellent question. So first, in terms of security, I'll start with the cloud, go all the way to the edge. Predix is a paranoid system. In other words, each one of the layers in Predix assume that every other layer got breached. So if you think about, let's say, 1 billion compute cycles, most companies will look at that and make the decision that 1 billion compute cycle, they need probably to allocate 900 million for the execution, and let's say 100 million for security. We actually took the slider along the lines of 600 million cycles for execution and 400 million cycles for security. So what happened is that first, our effective compute cycle is more expensive than others, and we are very proud of that. We are not hiding that. And the reason we're doing it is because there are many more compute cycle allocated to all this handshake between the various layers, even within the cloud. So this is one area of security that we believe, we went beyond, let's say, the requirements of the federal government, but also beyond what our customers would do. Because the discussion that we have with them always start, well, I have my chief security officer. Yeah, but with all respect, it supports 100 assets. We support 100,000 assets. So we can allocate much more than that. If you look at the other side, there is actually, you answered your own question. First, we apply a lot of anomaly detection. So we build multi-dimensional model for what we expect. And if certain things are not happening at the level that or at the time, or at the phase that we expect them, or we expect them to be, then we start raising all kinds of red flags. Security officer is seeing the vulnerabilities or suspect vulnerabilities, and we can test them. We also doing it the old-fashioned way, which is deploying a red team to go and just basically hack into the system all the time. We have I wouldn't tell you exactly for obvious reasons how many people, but we have quite a few people that it is their business to hack into the system and tell us what went wrong. So I think at the level of pen testing, we are actually pretty high up there. We have multiple controllers, we have multiple devices, but the controllers actually are very similar. So forget about the wind turbine. The controller that actually controls the wind turbine is pretty much the same thing as the controller that controls the gas turbine. And when we look at that, we are actually built a very similar system view. And so Predix does not necessarily connect. It's not like universal plug and play or USB where everybody bring their own device, and there's going to be a very easy open to everybody standard that they connect those devices to the rest of the fabric. In our case, we ask for a little bit more, and the protocols are different. One of the things we're trying to do, by the way, which may be of interest for you, is build the open source, and that's also a question to Ravi's answer to Ravi's previous question. We're trying to build the open source equivalent for the industrial protocol. In the industry, you have multiple protocols that actually don't help security. You have CAN bus and Modbus and OPC UA and MQTT and all kinds of protocols to allow you to move industrial data around. One of the things we're doing, and we would love to work with companies in this room or outside this room, is actually build a free open source protocol for the industrial internet, where the handshakes are going to be contractual. You know, you mentioned blockchain, and this is one of the technologies we're looking into to see that we can create a protocol that is open for everybody, and yet is going to be more secure than any of the proprietary protocol. If you think about that in terms of commercial, think about it, 50,000 billion, unlike TCP/IP, all these protocols actually, you have to pay somebody money, because PTC has just acquired a company called Kepware, and Kepware will charge you for licensing the protocol. At 50 billion sensor, they should make hundreds of billions of dollars. The industry doesn't have hundreds of billions of dollars to pay them, and actually doesn't want to pay them. So we will have to come up with an open source protocol for that. It's going to be a very interesting thing to work on.
Next question.
From your talk, I gathered that there's a lot of opportunity in industry, especially with digitization, yet I also gathered that this is not capitalized on right now in industry. What do you see are the big hurdles right now for industries to get there, and what do you think are some of the first steps that are going to really have a lot of traction towards getting them more towards a digitized model? Such as you said, rather than I give you an engine, I'm going to sell you thrust, essentially.
Yeah, so great question. I think Predix is the first, at least the one that I know, is the first attempt to go and open the boundaries of what you would like to do. So at least you see, as you said, I absolutely agree with it. There's more hole than cheese, but at least you see the boundary of the hole now. Now you can actually plug it in a much more efficient way. So the thing that we're going to produce, we're working on building, and we're going to release, hopefully mid-year, is a lot of simulation that will allow you to see how a wind turbine is working without owning one yourself. Assume that you don't want to own a wind turbine on the roof. Okay, so if you do that, you'll be able to see what's missing, and then start basically offering the right analytics about that. If you want to know the areas that we are not struggling with, but we don't have, I believe, enough investment, and we're going to up it in a dramatic way, it's really on the deep learning machine learning stack. I'm a big fan of TensorFlow. I think that TensorFlow can actually allow us to build great machine learning stack, but we need to go beyond that. Google has not opened a distributed fashion of that. We need to build something that will allow us to become much more scalable. And the nature of the business is such that you need to have a lot more training data that you will get from, let's say, a handwriting recognizer or a voice recognizer. So the amount of the training data sets, the validation data sets are such that we need to create also another layer of ingestion to allow you to do that. But this is going to be, in my opinion, that's going to be an area that is going to have a lot of activities, and we would love to work with the community.
You're saying it's the data ingestion.
Data ingestion is one, but the improvement of machine learning stack, especially if you start with TensorFlow or Torch or any of the other open source systems that are available, the extension of them to industrial system is not there yet.
Next question.
Yes. Hi. Thank you so much. I know that you are one of the founding members of the Industrial Internet Consortium, which is a really exciting development. Do you feel, and there are other platforms as a service out there, do you feel as though you have competitors?
Yeah, absolutely. We are, look, IBM, Bluemix is making the noise, and actually more than noise. They just cut, I think, a $700 million deal with Emirates, I think. So, you know, companies are looking at that, and actually the one thing that, I'm not sure if I need to laugh or cry about that, is that the fact that every IoT conference now starts with, you know, not with the Fitbits, but with, you know, the turbines. So I think that there's no doubt, I know that we have competitors. IBM is a big one. You know, SAP is definitely trying to be in the space. Caterpillar is trying to be in the space. There's a bunch of companies that are trying to do that, but it goes back to what I said before. At the end of the day, many of those companies will realize that they need to find somebody that is willing to spend big. It can be us, it can be IBM, it can be maybe Microsoft, that is willing to spend big on these things. By the way, the Industrial Internet Consortium is actually putting all these competitors together, and we're working on things that we all would like to solve, like test beds, right? How do you make sure that your innovation can work? And that's the charter of the Industrial Internet. The interesting thing about the Industrial Internet Consortium was that I talked to one of the companies that said that they got a lot of crap from other people because they blame them, how dare you, join a forum that is governed or is dominated by GE. And in reality, this forum is no longer dominated by GE. It's governed by GE, or it's co-governed by GE, but we see a lot of our competitors, stepping up. So we are working with them. It's a competition world, right? So we're working with them to build the test beds and work on things that are important for our customers, because as I said, customers are multimodals, and we'll try to compete with them on taking the business away, no offense.
Is there any other company that's addressing the sovereign critical data issue, sovereign critical infrastructure issue?
Well, if they don't, they won't be able to be in business. So I'm sure that all of them are trying to address that. Some of them are more efficient than others.
Thank you.
Hi, I have a short question. So that sounds all really exciting. It almost sounds like a new industrial revolution. And it sounds also like you're saying there are some competitors, but I guess GE is kind of interested to make this like the most powerful platform. And the internet has shown it usually leads to monopolies. So is GE trying to build a monopoly here in this whole market?
I wish we could, I can tell you. But the last time I did that, the DOJ came and gave me office cleaning service free of charge. So, look, I don't think that we will, as much as I would like to between us, folks, I don't think that anybody will be able to repeat the same act that made Microsoft in a monopoly. I think that we will try to compete. In software business, sometimes you have, rather than 20-20, 20-20 division, you have 70-30 or 70-25 and 5. Obviously, would like to be to grab the largest market share, but this is not going to be a monopoly. I cannot even, as much as I would have liked it, I cannot see how it can become a monopoly. Our customer will not allow us to do that, because customers love us, but nobody wants to be, held by all kinds of extremities by their supplier.
Okay, and who do you see currently as your two main competitors?
So I think I would say that Siemens is definitely a competitor. Siemens and what they're doing with SAP, and on that, the Industry 4.0 verge is definitely a competitor. I think you'll see Caterpillar and Uptake, are trying to stage a competition. I think that the normal IT providers, either AWS or Microsoft, it's just a matter of time before they jump in. And so I think we're going to have about 4 or 5, really serious competitors. I think that Google is going to be behind. They don't seem to find a lot of interest in this industrial ecosystem. But if they go into autonomous cars, they can go into autonomous, earth-moving equipment, which is actually becoming industrial. So I think that the situation is going to be really exciting, really interesting, really hot by the end of, let's say, 2016.
Okay, I'm very excited. Just one last question. I really like the digital twin, and I was just wondering, when all this data is out there, will then prices, for example, for airplanes change depending on how old the turbines are? Like if I know this turbine might break soon. I'm not going to pay as much. It's a brand new
I
turbine.
think the airline would like to keep the money for themselves, but that's between you and the airlines. You know, don't buy their stocks.
Let's take 2 more questions and then we'll call it a night.
So in terms of I just have different kind of question. In terms of educating customer versus learning from customer, which one is more important?
In terms of which learning from customer and
Or
Educating customer. For example, do you think G knows turbo engine more, or Boeing and Airbus knows turbo engine more?
Well, I think that, for instance,
It looks like what the 4,000 people team can be accomplished with for the superstar team, I guess.
Okay, so we are not trying to tell our customers how to run their business, and we're definitely not trying to tell Boeing or Airbus how to run a better airframe. We don't know anything about airframe, but what we can do is give them the platform to allow them to build something to deal with their customers. We are the plumbers, right? So we don't care what's happening above that. We will build the 5, 6, 7 applications that we believe we know how to do, and we're going to leave the rest to our customers. And if they want to use us, great. If they want to use AWS, it's less great, we think, but at the end of the day, we're not trying to go all the way to tell our customers how to run their business. We give them what we call insights, and we suggest to them outcomes. They want to take it, great. They don't want to take it, that's fine too.
Great, thank you. Any other questions?
Yeah, one more here.
One more, go ahead.
In there.
Yes, sir. I have a quick question about the current infrastructure. If you walk into factories or oil and gas plants or food processing, they have really old SCADA systems and really old. How does GE plan to kind of retrofit or go back and kind of rip those things and put the new smarter systems in place, right? Because that's going to be one of the challenges, whether it's for a startup or for a services company going in there.
It reminds me of a story. There was a very a good Samaritan, that was really, really poor, and at a certain point, the angels look at him and they said, look, they went to God and said, God, you have to help the guy. He's great. Just make him, win the lottery. He said, that's fine, but first he has to buy a ticket. So, it's the same thing. If you look at the SCADA systems today, they're actually not connected to anything. It's impossible to do brilliant factory if they're not connected. So the first thing we're doing in GE factories is that we are revitalizing, the IT connectivity layer in such a way that those SCADA systems will be connected. Once they're connected, it's much easier to actually get more out of the SCADA systems, because you don't have to replace the SCADA system. What you have to do is take the data, analyze that, and actually add to the knowledge that the machine operator has, or the factory manager has, so he can know or she can know what exactly is happening. Today in factories, the shift supervisors don't even know what is percentage of the time the machines were running. So even simple thing like allowing the operator to actually signal the machine starts and then allowing the operator to signal the machine stop are things that are not supported. So we have a lot of work to do, but the good news is the bar is so low that we can actually have significant improvement over time. And by the way, we're not the only one. I mean, if you look at Coca-Cola, you look at PepsiCo, look at GM, they're much more sophisticated sometimes in the manufacturing. There are robotic arms and a bunch of other things, but they don't have the connectivity of everything that allows them to control the whole factory from a single pane of glass. Or they don't have the analytics that allow them to understand exactly what is the theoretical limit on the manufacturing capacity, and then work from that. So I think there's going to be a lot of things that we'll be able to do much better in the future.
People are not ripping out SCADA systems right now.
Yeah.
Great. With that,
One more
question. Okay, last question.
Yes, my question will follow exactly on what you just said. I'll go back first to your model of the jet engine. GE has enough capital to shift the model from just selling the engine to leasing the engine. But for most of the other manufacturer, capital equipment manufacturer, I guess there's not enough capital to do that. And currently in most models, they sell the machine, but also the part of their income, a significant part of their income comes from the service stream. Now, we've pulled it with the digitalization. It seems to me that what is happening is that you are allowing to break the activities, whereas in the past they were controlling everything from the design, the manufacturing, the service. I can see a place very soon where the service part will be a different type of business, since once we have the data, anybody that understands the technology, they can look at the data and make sense of it, can compete against them on the service side. And then what I observe, and there's a debate in this, and I would like your input in that, is who owns the data? Because when I look from some of those manufacturers, they have this question, they believe that they own the data, or in cases where they are not sure that they have a legal case, they have been thinking about encrypting the data so they will keep control of the data to prevent anybody from getting to that part of the business. What is your vision on that? And how does GE, I mean, I guess you probably thought about it. What's your vision? What
a great question. Who owns the data?
It's really an awesome question. Well, but I'll go back to your first part. By the way, Predix is the reason we did Predix is exactly what you said. We ourselves got really, really concerned about the disintermediation, right? All you have to do is take the data that we create, well, that our machines create, our customers are using into Splunk, and you can actually get a big part of that already, a lot of insights, a lot of outcome, and so you really don't, you reduce GE to commodity, to a bunch of part suppliers. So that's why we created GE. But when we do that, first, we realize that as the owner or the manufacturer of the data, we have digital rights, or co-digital rights. We are in many cases, we are the co-owner of the data alongside with the customers. The customers actually allowed us to take the data so we can actually give them better maintenance. Now, there is an interesting question of what happens if we're not the maintenance guys, right? So United Airlines maintain their own engines. But at that point, if that's the case, then United Airlines Chief Security Officer can argue that GE Aviation is not entitled to the data, and if that's the case, Predix will comply with that. As I said, Predix is digital Switzerland. If you don't want to give GE the data, don't give the GE the data. Just keep it in Predix. It doesn't mean that GE can see that. We will connect the customer to the maintenance provider. And so if that's how the customer wants to do that, or the customer to the customer itself, if the customer is self-maintaining. But the idea is that we have certain rights. In certain cases, the customer decided not to give GE the rights and GE could not negotiate. And so we don't have the information, but that doesn't mean that you don't need a system like Predix, it can be from somebody else, to go and analyze that. And we would argue that if you are putting in Predix, you should not be concerned about GE having a backdoor into it.
Yeah. So to follow up on that, that is good moving forward. But how about the legal systems? Because I guess all these questions were not really important 20, 30 years ago, but since we have a huge legacy of instruments and machines out there, what happened for company that will seize that opportunity to go back and digitize those existing assets to build solutions like Predix or others?
So I think there is a whole playbook of who owns the data. I mean, think about Splunk. You give the data, you can put the data in Splunk, but you are the only one that owns the data. Now the question is, can we look at multiple SCADA systems and start, building something? And the idea, our customers are very happy with us doing that, as long as they get actually the results of the data back to help them, right? So many of the deals that we cut are deals that allow them to give us the data, and in return, we provide them the insights, from their data and other people's data, because you want to see a fairly broad spectrum of the same devices with the same behavior and start, basically doing analytics. I think it can go back to legacy system. The interesting thing is that the real legacy system, legacy data was never stored because company did not know what to do with it. And why would you store something you have no way of deriving value from? Now, everybody starts to realize that there is a way to optimize that. So now the game starts getting much more interesting.
Okay, thank you.
Thank you.
Thank you.
Today, and I want to thank Deepak Krishnamurthy and his team at SAP for hosting us. I'm sure Harel and Deepak and others are going to be here for a little bit, so feel free to come and ask him any questions. Thanks.